So here we go. We're going to start on our first virtual notes for the year. We got Chapter 1 notes, Lesson 1, rational numbers. Our goals today, our objectives are to write fractions as decimals. Write repeating decimals, both terminating and non-terminating, as fractions. So writing decimals as fractions. And then identify rational and irrational numbers. All right, that sounds like a load of fun. All right, these are the foundations. These are the foundations that you're going to build so that you can do amazing things when you grow up, okay? So trust me on this. Learn this stuff well, and it can kind of widen your base so that you can build on it later and have a strong foundation to grow from. All right, anyway, we got rational numbers to start. You should have picked up these definitions already from Quizlet. And just a couple little points that I want to make as we look at them. So rational numbers, you see the word ratio hiding in there, right there. And that goes along with the definition. Numbers that can be written as the ratio of two integers. So basically, it's a lot of the numbers that we're familiar with already. They're rational numbers. We're going to deal with irrational numbers and this year. And if a number is a repeating decimal or can be written as any sort of terminating decimal, then it's rational. Okay. Also, if we can write it as a ratio or sometimes another similar word to ratio with a similar meaning as ratio is fraction. Okay. So if we can write a number as a fraction, it's definitely a rational number. All right. Repeating decimals. Guess what? All rational numbers can be written as repeating decimals. Okay, so that's why the definition is just, what is a repeating decimal? It's the decimal form of a rational, I forgot the AL, rational number. All right, and a terminating decimal is just a special type of repeating decimal where the repeating digit is 0. All right, and terminating, I'm not sure if you know of this old movie, only old people like me know, but terminating, like the movie Terminator. Well, so for instance, a terminating decimal would look something like this with a bunch of repeating zeros. All right, and I think of that like we don't need any of those, right? We don't need any of these zeros at the end. Okay, we don't need any of those, but I think of it to remember that it's a repeating, a terminating decimal is just repeating zeros. I think of my man Arnold Schwarzenegger here. You recognize that guy? Well, in this movie, he's like this psycho robot dude who is trying to defeat the humans, and he kind of shoots a lot of things. So I just think, the saying "I'll be back." He says that in one of these movies. So anyway, I think of him as like using his gun and blasting holes through. Okay. And so the Terminator makes all these bullet holes zeros. See, they look like zeros and bullet holes. See what I did there? All right. So anyway, Arnold. I'm sure some of you have good Arnold impersonations. We'll have to hear those someday. All right. Let's go on to the meat of the lesson here. Write. Excuse me. Don't worry, I don't have COVID. Write fractions as decimals. Okay. This is a skill that you have practiced before. We are simply going to convert these fractions to decimals. Now, there's several ways to do it. The foolproof way, the way that works every time, is going to be to turn it into a division problem because a fraction can be thought of as division. This is 5 divided by 8. So we make our little bar here, and a lot of times people put the wrong number for long division inside of the division bar here. So one way that I think about it is I always think of the top dog. Top dog, see, he's the 5's on top. The top dog gets the doghouse, right? Top dog. If I'm the top dog, I'm not going to be sitting out in the rain, right? I'm going to be in the doghouse, all comfy and cozy, while the little guy that's under me, he gets to stay out in the rain and deal with it. All right, so top dog, this guy's the top dog. He gets doghouse, you put him in there, and then we long divide. All right, 8 can't go into 5, so I have to add a decimal here and put my 0. 8 can go into 50, goes in 6 times. Now we do 6 times 8, 48. Subtract, we get 2. We bring down a 0. 8 goes into 20 twice. 2 times 8 is 16. Subtract, we get 4. Bring down the 0. 8 goes into 40 5 times. If you need practice on this, just email me, and I can give you some resources that will help you remember how to long divide, especially it could be tricky a little bit with decimals. Okay, now is that reasonable? Is 5/8, right? That's 5/8, 5 out of 8. That's a little more than half. And is our decimal a little more than half? I would say yes. 0.625 is a little more than half because 0.5 is half. So 0.500 would be, and then 0.625 would be a little more than half. Okay. Here, number 2, we can make a point here that some people get confused with mixed numbers. Well, first thing when you see a mixed number and you're trying to change it into a decimal is just take this integer part of that number and write it down. -1, and then you have the point part. The decimal part is what we have to deal with. So that 2/3 is going to be what we're going to long divide to get the decimal piece of this problem. So we're going to put the top dog inside and the 1 on the bottom, the denominator number on the outside. Also, 2/3 is a common decimal. So like, for instance, I know just off the top of my head, I remember that it's going to be 0.6 repeating, just like 1/3 is 0.3 repeating. That's something that you should have memorized right at this point. If you don't have it memorized, like I said, your fallback plan, your foolproof plan is to just long divide. So 3 goes into 2, can't. So now we need to add our decimal and add our 0. 3 goes into 20 6 times. 6 times 3, 18, minus gets you 2, bring down, oh no, we got another 20, goes in 6 times, 18. Okay, we see that that is going to keep going and repeat. So we know that what I said originally, what is true, is right. And so our answer is -1.6 repeating. All right, well, we have some gottets here. So what I want you to do is to pause the video and try these yourself. Actually, don't pause, because I'm going to do this next one, and I'd like you to just follow along. So let's just follow along on these last couple examples, and you can try it in our homework tonight. All right, 3/4. Well, quarters. You should know that a quarter of $1 is 25 cents. So if you have 3 of those quarters, you're going to have 75 cents. That should be one of those that is just already in your brain, ready to roll, that you can just convert on the fly. All right. 2/9. All right. One problem we have when we have negative fractions is in our answer. We don't put the negative sign. So I'm just going to throw it in there already. And then 2/9. I put the top dog inside. And I put the 9 on the outside, the denominator on the outside. Now, I know a trick for this one. But if you don't know the trick, you can use your backup plan, which is long divide. 9 does not go into 2 evenly. So put a 0 there. Carry the decimal up there. And put our 0. So 2 goes into 20. 9 goes into 20 twice. 2 times 9 is 18. Minus, we get 2. Bring down. And we get another 20. And that's going to just keep going with 2's. So then we have -0.2 repeating. And the trick here, just like, let's say 3/9, because that equals 1/3, and we already talked about that today, that's going to be 0.3 repeating. All right. Whatever's over a 9 is what's repeating. So let's say 4/9. Guess what that is? Can you find the pattern? Yes, that's going to be 4 repeating. All right. 8/9 equals 0.8 repeating. Okay, so there's a little trick for that one, but if you forget the trick, then just go ahead and long divide. All right, now this one brings up an interesting problem. Now you could long divide this, or you could realize that that denominator right there, that 25, goes evenly into a power of 10. It goes evenly into 100. So what we can do here is we can make an equivalent fraction. All right, make an equivalent fraction with a power of 10 as its denominator. So 25 times 4 gives you 100. And what you do to the bottom, you have to do to the top. So 13 times 4. And that gives us 52. Now, I did that in my head. Actually, I did it earlier, and I'm just remembering it. But anyway, 13 times 4, you can always just do it like this, right? Carry and 52. Okay, and that's 52 hundredths. All right, so now we know 52 hundredths is an equivalent fraction. So we have 4 and how do I write 52 hundredths as a decimal? Well, we have tenths hundredths, so 52 hundredths is going to be written like that, 4.52 or 4 and 52 hundredths. So that is our answer there. Now remember, you could long divide that fraction to get the same answer, but I think this is a little bit more simple. Now this is just a tricky one. 11ths are tricky because 11 is a weird number, all right? So I believe we're just going to have to long divide this. So 3 point, all right, we're going to put the top dog in the doghouse. We're going to put the denominator on the outside. It doesn't go into that. So we get 0, and does 11 go into 10? No, it doesn't. So now we're going to need another one. All right, and now we have 11 goes into 109 times. 9 times 11 is 99. Oh boy, this looks fun. So then we get 1 again. All right, we bring down. 11 goes into 10. Oh, no, it doesn't. We got to bring something else down. And now it goes into it one more time. So that's 09. So what repeats? The 0, the 9, or both? If you said both, you are correct. It's going to repeat 09. We have to put the bar over both of those. So 3.09. 3.09 is the answer there. All right. We are moving right along. We are going on to our next section. A little word problem here. Now, this one I'm going to actually just show you. In the textbook, it actually asks you to use a calculator for this, but I did not copy that down. So I'm just going to put on here how you would type that in. So we've been doing where, you put, so for this, the first baseman, Albert Pujols, had 175 hits in 530 at-bats. To the nearest thousandth, find his batting average, okay? So if we were to write that as a fraction, we would write it as 175 out of 530 total at-bats, okay? And it's asking us to find the batting average, which is really just a decimal version of that fraction, but without the decimal. So if you don't know much about baseball or haven't heard of batting average, then you would be pretty lost at this. But you could always Google, how do I find someone's batting average? Or what does a batting average mean? All right. So anyway, it's just the decimal form of how many hits they have out of the total at-bats. So if we were to do that, we could do 175 and 530 out here. Now that would be a just terrible problem to have to do. So it does ask you to use a calculator, and in that case you would write this 175. You type that in, then you'd hit the division symbol, 530. Okay, 175 divided by 530, and then that would give us our answer. And our thousandths would be 3 decimal places, so tenths, hundredths, thousandths, and we round. All right, now if we do the got it here, we are going to actually divide this. It gives us a nice little shortcut for special types of fractions here. So it says NASCAR driver Jimmy Johnson won 6 of 36 total races. What we know about fractions is we usually put the part over the whole. So the 36 is the total, and the 6 is the part that he won. So now this little star hint is always look. If you have to change it to a decimal, always look if you can simplify that fraction. Simplify that fraction, and then we'll have smaller numbers to long divide. All right? Or it might actually simplify down to a fraction that you already know the decimal for. Okay, so 636 looks like a terrible fraction to find the decimal. So what we'll do is we'll simply simplify it by dividing the top and bottom by 6. And we get 1/6. Now that looks a lot more simple. So we're going to put that 1 in the fraction. In the division bar here, the little house for the top dog, and we're going to divide. Well, it doesn't go in, 6 doesn't go into 1, so we need a decimal and a 0. 6 does go into 10 one time. 1 times 6 is 6, minus, we get the 4, and we need another 0. All right, 6 goes into 46 times. 6 times 6 is 36. Subtract, we get a 4. Bring down another 0. It looks like we're going to have some repeating decimals going on here. So 6 goes into 46 times. Now, we had a decimal earlier that repeated 2 digits. This is different. It has 2 digits, but only one of them is going to repeat. So you have to be careful to write that correctly. So when you write it, it's going to be 0.16, but that 6 repeats. The line can't go over both of those because the 1 does not repeat. So only the 6 repeats. So here is our answer, and that is, it's not exactly our answer, actually. It says round to the nearest thousandth. So we should actually go like this. 0.166, that's the thousandths. What is the next digit? We have to know that to be able to round it. So it'd be 0.166 because it's repeating. Now that this digit here tells this digit, if the following digit is 5 or more, then our thousandths place is going to round up. So our actual answer is going to be 0.167. There you go. 0.167 is the part of the races he won. Okay, so now you can, we've had a good idea of changing fractions to decimals. Now we're doing decimals to fractions. And the simple method here is find the place value, right? Tenths, hundredths, and that's your denominator. Whatever the place value is, that's your denominator, and you put the decimal on top. Okay, so 45 hundredths, and then simplify. Looks like we can divide by 5. Divide by 5, we get 9 twentieths, and that is our fraction form of 0.45. Okay, 125.125 is a fraction. Well, that's tenths, hundredths, thousandths, so 1,000 goes on the bottom, and then we put the decimal on top. All right, now I happen to know that simplifies down to 1/8, and I think that's something you learned in 6th grade, what the eighths are. That each eighth is 0.125. All right, oh boy, what is this thing? Write 0.5 repeating as a fraction? Is that really a repeating number there? Okay, well, we're not ready for that, and we're not ready for that. That's going to have to wait till our next lesson. All right, hopefully it wasn't too painful, this first digital lesson. Hopefully you got something out of it, and let me know what you need help with. Thanks a lot.